Hello and welcome to today's class. So basically, this is a continuation of where we left at in the previous video. So we have a problem here that's find the equation of a curve whose gradient function, all right, is given by dy dx being equal to 2x plus 3. All right, so we have the gradient function of this particular equation as 2x plus 3. And that the equation of this curve actually passes through the line 0 and 1. So we are supposed to find the equation of this particular curve. Of course, we know that for us to find the equation of the curve given the gradient function, we have to basically integrate, which we said was the opposite of differentiation. So basically, y given that this is our dy dx, all right, will be equal to 2x. Remember what you were doing, whatever we have in the index plus 1. So, all right, and then we divide everything by that, all right, okay, plus, so here we are having 3. And so, though x has not been notated here, the value of x here is actually raised to 0. So anytime we say that anytime a number is raised to 0, it's equal to 1. So that is why you are not seeing x next to 3 there, okay? But actually x in this particular case is raised to 0, okay? So we're going to have 3x raised to 0 plus 1, okay? All right, and so whatever we get out of that, we're going to divide by the whole term, so that's going to be 0 plus 1, of course, and everything then plus c, which we said is supposed to be the y-intercept describing the equation of this particular curve, and that is the point of intersection between the curve and the y-axis in the Cartesian plane. And so let us go ahead and simplify the whole equation of y here. And so we're going to find that y in this particular case equals to 2x raised to 2 divided by 1 plus 1, there is 2, okay, plus 3x raised to 1, 0 plus 1 will be 1, right, all over 1, okay, plus c. And so this simplifies to 2 divided by 2, and that's going to be x squared plus 3x plus c. Okay, so this here is the general integral equation of the curve, okay, that we were trying to find based of this gradient function. All right, however, it is not complete. Why? Because we haven't found the value of c, which apparently we can find, all right, because we've been told that this equation of the curve actually passes through the points 0 and 1. So we've been given the value of x and y. So this is the x and the y value, which we can actually substitute directly into this equation to find the value of c. And then, of course, rewrite the whole equation as complete as it should be. And so for us to find the value of c here, we are going to substitute where we have y, we're going to have 1. Okay, so it's going to be 1 equals to, and where we have x, we're going to put 0. So it's going to be 1 equals to 0 squared plus 3 into 0 plus c, okay? And so basically that means therefore that the value of c will be, okay, this is going to be 1 being equal to, this will be 0, this will be 0. The value of c basically will be 1, okay? So we have found the value of c. So to find the equation of the whole curve, we'll basically have it rewritten as y equals to, okay, we come back here to this equation that I've now labeled equation 1. We're going to have it as y equals to x squared, okay, plus 3x, okay, plus the value of c we found, and now it's 1 plus 1. And that is it. So that is the equation of the curve whose gradient function is 2x plus 1 and passes through the point 0 and 1. So the y-intercept in that particular case is equal to 1. All right, so this here is the integral function of dy dx equal to 2x plus 3 and passing through the point 0 and 1. Let us tackle the last example in this particular class, then call it a day. All right, so welcome to the second and last example. All right, so we are having a question here that we are supposed to find the function v in terms of h if the derivative of v with respect to h is given to be 3h squared plus 4, and that v equals to 9 when h equals to 1. So we are going to basically first of all find the integral of the derived function, that is dv dh, all right, and then use the values v9 and h1 to find the value of c, to then write the whole complete equation of v. And therefore, notice v will be given by 3h is raised to 2 here, so it's going to be 2 plus 1, okay, divided by 2 plus 1 there, all right, plus 4, okay. So in this particular case, okay, our h is actually raised to 0, okay. Our h is actually raised to 0. Remember, any number raised to 0 is always going to be equal to 1, and so we don't write the we don't write a variable that is actually raised to 0. We just ignore it. And so h is raised to 1, and so we're going to add 1 to it to find its integral, and so that's going to be 0 plus 1 dividing the whole term afterwards, plus our constant c. So this basically will simplify to v being equal to 3h cubed, okay, divided by 3 plus 4 raised to 4h all over 1, okay, plus c, which we can simplify, and then 3 divided by 3 will give us h cubed, okay, plus 4h plus c. Okay, so I'm going to name this here equation 1, okay, as it is not complete yet. We haven't found the value of c, and we are supposed to find the value of c, and then then write a complete equation from whatever we have as equation 1. Remember, we've been given the value of v as 9 when h equals to 1, so we'll substitute these values directly into equation 1 to find the value of c. And so 9, that is in place of v, we'll have 9 equals to 1 squared, 1 cubed actually, okay, plus 4 into 1 plus c. And so notice that to find the value of c here, we're going to take 1 cube is 1 plus 4 into 1 is basically 4. So that's going to be 1 plus 4 giving us 5. So basically we're going to have 9 minus, okay, 4 plus 1 is 5, so we'll take the 5 on the left hand side, and so that's going to be minus 5. So it's going to be 9 minus 5 giving us c. All right, 9 minus 5 giving us c. So this here is the value of c. That there is the value of c, which we can then go ahead and substitute into equation 1 to write the all complete equation. And so v based on equation 1 will be given by h cubed, okay, plus 4h plus, oh, this should have been 4, okay, plus 4. All right, that is based off of this, that 9 minus 5 is equals to 4. So the value of c is equals to 4 there. So, and that is our final equation for this particular problem. Thank you, and have a wonderful time. If you have any question, drop it in the comment section and I'll get back to you. Thank you and have a good one.